So let me give you brief synopsis for motion in a straight line. Matlab 1D motion. So the first thing you should know is, since it is motion in 1D, we will talk about motion in a line. Let us call the line as x-axis. Every x-axis is a scale only, and every scale has a origin. So let's say the particle is here. This is called coordinate. So this is called your coordinate. And if the particle is moving, this x will change. So when x will change, that delta x is called displacement. Okay? That means displacement formula is what? Final x minus initial x. It can be positive, it can be negative, it can be zero because there is a minus sign. So if you go this side, x2 final will be more. If you come this side, final will be less because you are coming near to origin. So if this is more, positive. If this is less, negative, this side. And if these two are same, when these two will be same, when you come back to the same point, that time displacement will be zero. Distance doesn't have any formula. Distance is basically path length. Path length. So I can't give any formula for distance because that depends on the length of the path, how you go. So if you go like this and come back like this, distance will be this plus this. Only the length you have to add. Length, not the, don't subtract the coordinates. That you have to do for displacement. Then average velocity, if they ask, then for this I can give you formula, displacement by time taken. I can write sometimes displacement as just s also and time taken as just t also. When will be time taken t? If you start from 0 time, obviously. And what will be average speed? Average speed, if they ask, then again I cannot give you formula because distance depends on the length, the path. Distance divided by time taken. Then if you want instantaneous velocity, then it is dx by dt. And if you want instantaneous speed, then it is just the magnitude of velocity. Okay? But don't say this is magnitude of this. Why this is not magnitude of this, but this is magnitude of this? Instantaneous speed is magnitude of instantaneous velocity. But why not magnitude of average speed is average velocity? Because suppose I go like this. Suppose. Then this is my distance. But this is my displacement. So they are not same. So if distance and displacement are not same, how these two will be same? If I go in a curved path or even if I go in a straight path, if I come back, then distance will be more, displacement will be less. So these two are not same. So don't take magnitude of this and don't think you will get this. But this is instantaneous. No, instantaneous. No. You will go from here to here or from here to here only. Instantaneous means from here to here only you will go. So if you go from here to here like that small path, then that small distance and that small displacement are same. Only difference is displacement we say direction also. Distance we don't say direction. So in that case, if it is small interval of time, then this distance and this displacement are same in magnitude. So in that case, if distance and displacement are same in magnitude, velocity and speed will be also same in magnitude. So if they say instantaneous, they are same. If they say average, they are not generally same. When will they be same? If you go straight and don't come back. If you go straight, then distance displacement same. Then if I ask average acceleration, then it is change in velocity by time taken. Some people also write v minus u by t. This is average acceleration, okay? And if they want instantaneous acceleration, then it is just dv by dt. So these are the main equations. Now, if velocity is constant, if you move uniformly in a straight line, if velocity is constant, then in that case, your average velocity will be same as instantaneous velocity, and therefore you can write s by t, or you can write dx by dt, doesn't matter. Okay, students? So if you move with constant velocity, if all of you have same marks, then it doesn't matter whether I ask average marks or one of your marks. Similarly, and acceleration will be obviously zero because velocity is constant. So differentiation will be zero. Similarly, if A is constant, then average A will be same as instantaneous A. And average A, I wrote here B minus U by T. That will be same as dV by dt also. So all these things you try to remember. Now, there are few equations which are very useful provided if A is constant. What if, sir, A is not constant? If A is not constant, then we have to use calculus. Calculus matlab start from definition of instantaneous acceleration. What was the formula, sir? A equals to dV by dt. No, I told. Then the rule is, Saint Benedict people know nicely, cross multiply, integrate. So that is the rule, but we will do problems, don't worry. But right now we will not use calculus because we will try to focus on problems where A is constant. Best example is free fall. In free fall, A is how much? 9.8, which we write G, direction we take down. So this is the best example of A constant problems, free fall. Free fall means the only force acting is gravity. And if this is the only force from Newton's second law, we know acceleration is force by mass. That's why acceleration will come G, direction we know downwards. So if A is constant, then we have some nice formulas. First one, V equal to U plus AT. That too I told you here also, see? Yes or no? If A is constant, then average A definition is this one. Delta V by delta T. See, average matlab delta Y by delta X, average. Instantaneous matlab dy by dx. If y changes with x. Here we are talking about with time. So if A is constant, the first equation is V equal to U plus AT. Then S equals to UT plus half AT square. Then V square minus U square equals to 2AS. The fourth one is V plus U by 2. This is your what velocity? Average velocity, because A is constant. If A is constant, your velocity will increase uniformly. Velocity will increase uniformly matlab every second the change in velocity will be same. Sir, I did not understand. Arey Baba, when people say acceleration is 10 meter per second square, what does it mean? It means 10 meter per second. Yes or no? That means your velocity changes by 10 meter per second every second. So every second velocity will change by 10 meter per second. So if you drop something, it will start with 0 speed. After 1 second, 10 meter per second. After 1 more second, after 2 seconds from the start, 20. After 3 seconds, 30. Like that, the interval will be same. So whenever a function will increase linearly, that time the average of that function is simple, initial plus final divided by 2. But remember, this can be done only if A is constant. Now, average velocity formula I also told is displacement by time. So this is also a very useful formula in some problems. Okay, because this formula doesn't need you to find what? This formula doesn't need of which variable? In all these variables, in all these three equations, that variable is sitting. But here that variable is not sitting. Who is that variable? A, acceleration. So in problems where you don't care about A, that time you have to go with this. And then you may be sometimes interested to know displacement in nth second. If you want to know displacement in nth second, the formula is u plus a by 2 2n minus 1. Okay, so try to remember these equations. Now, how to use these equations? Very simple. First, you have to find the path. Let's say this is your path. Okay. This kind of path, where will you see? Here you see, example you see. This one, up, then down. Of course, it will be in the same line, but for clarity, I have shown separately. This is not straight line, no. This is straight line, ah. So actually, the motion is straight like this, then straight like this. But for clarity, I have shown separately. So this is your path. Now, first decide your time taken. Matlab, initial and final. So let's say this is initial and this is your final. This also could be your final. This also could be your final. Any point, any 2 points you can choose. Then u matlab what? U matlab velocity here. So for finding u and v, you have to locate the point because these are instantaneous velocities. Instantaneous. So u is velocity at initial point. V is velocity at final point. Now, if you are this side, v will be here. If you are here, v will be there. So that depends. Okay. So v and u we came to know. T is time taken. T is time taken. You can see. What is S? S is the displacement. This is your S. From initial to final. Okay, students. Don't go like this. What is this? This is not displacement. This is distance. And these formulas only give you displacement. Then what else? A. A though is constant. So A everywhere is A. So I will not show everywhere, but you should know that as the body moves, it constantly feels acceleration. It's like this body. See, this is constantly feeling gravity everywhere. Hey, you feel gravity only here. Huh? Here you don't feel gravity. Everywhere you feel gravity, but everywhere I cannot show you A everywhere. No. So please understand A is everywhere, but U and V are at two specific points. Displacement is the distance between those 2 points, the shortest distance. That too from initial to final. Okay, so let's do some problems now. Let's start with the first question. A body starts with initial velocity 7 meters per second. A body starts with initial velocity 7 meters per second. And acceleration is minus 2 meters per second. Okay. So you have to find distance covered in first 5 seconds. So initial velocity is given, acceleration is minus 2. Minus 2 matlab the body starts with velocity this side, but acceleration is constant this side. Best example of this is what? This one. 10, na? Others also check. You may have done it this way. So S equals to ut plus half at square. Remember, t is measured from 0 to t. Okay, so t matlab first t seconds. What is initial velocity? 7. In first 5 seconds means time taken is 5 seconds. Plus half. What is acceleration? Minus 2 into 5 square. So 7 5s are 35. Minus 2 cancel. Minus 25 equals to 10 meter. Easy or not? Easy to easy, but this is wrong. Who can tell why this is wrong? Ah, very good. Now you are telling. So this is not distance. This is displacement, I told you. This is displacement. Question was to find distance. Now you will say, sir, it is straight line. Straight line. Yeah, it is straight line, but did you see where is A? A is ulta. So imagine you are coming like this, and there is strong wind in opposite direction. What will happen when the wind will hit you? You will slow down, slow down, slow down, slow down. Then you will stop. Then you will go back. So your motion will be like this. Now the question is, first 5 seconds will fall in this part or in this part, that we need to check. If it falls in this part, then no problem. Distance and displacement will be same. Alright. First 5 seconds they told. This is the starting P0, initial velocity. So as time passes, up to 5 seconds, let's say it is going straight only. Then no problem. Then if it is here after 5 seconds, then no problem, because then this will be distance, this will be displacement. Agree? Put thumbs up. But what if it is at 4 seconds, let's say it comes back, and here it is at 5 seconds. Now problem. Now problem, because now this will be displacement, initial to final, but this will be your distance, which is much more. Okay, not much more, but still still more. So whenever acceleration is opposite to velocity, the body will slow down. Mention that. If A is opposite to V, Puja started. Okay. If A is opposite to V, then the body will slow down. That you please remember. That doesn't mean if A is negative, it will slow down. Hey, hello. A negative doesn't mean the body is retardation. You are no longer in school. A negative doesn't mean retardation all the time. A negative means retardation only if U is positive. If velocity is positive, A is negative, then it is retardation. But sometimes it will be like this. Velocity is negative. A is also negative. Then the body will move faster. Then how will you say retardation word? Yes or no, students? Suppose I take down negative. If I drop this ball, velocity is also down, acceleration of gravity is also down. Both are down. So if I say down is negative, A is also negative, velocity is also negative, then it will move faster and faster. So don't say A negative means body will slow down or move fast. Don't say like that. This will decide if they are in same direction, positive, positive, negative, negative, then faster, faster. If A is positive, V is negative, or if A is negative, V is positive, then it will move slower. So this you try to remember. So now how to find distance in this problem? Very simple. First you have to find at what time it will turn. So at t0, it starts with what velocity? 7. Then it goes like this. Where it will turn, that time we have to find first. This is your time of turning. How will I calculate that time? Any idea? What will be V here? Velocity here. If it goes up to there and comes back. So at that point, what was velocity? 0. Because beyond that, it is not going. So V is 0. Okay. So V equal to U plus AT. Because I know V. V here is 0. U is 7. A is minus 2. So 2t will be 7. So t equals to how much? 3.5. Oh, that means our body will return at 3.5. Therefore, 5 seconds, it will be somewhere here. So now we have to break this motion into two parts. So once you know the time at which it will return, let us break the problem into two parts. From 0 to how much? 3.5 seconds. Let us call this A, B, and let us call this C, which is 5 seconds. It may be here also, I don't know. No, it cannot be here because displacement came positive, no. So I know displacement is positive. Plus 10 came, no. So once we have broken this whole journey into two parts, let us call this A to B. A to B, let us use our equation S equal to ut plus half at square. Or shall we use our that average velocity formula? No problem. This also will be okay only. So u is how much? U is 7. What is time taken from A to B? Time taken from A to B. 3.5 plus half minus 2, 3.5 square. That will be 7 into 3.5 minus 3.5 square. That will be 3.5 common, 7 minus 3.5. 7 minus 3.5 is what? 3.5 only. What is the answer? Calculate now, I'm feeling bored. 12.25. We could have used this also, I think. Check here. U plus V by 2 into T. Remember this formula I gave you? Average velocity is displacement by time also, no? So if I use this, how will I get answer? Let's check. U is 7. Here U is 7. Here V is 0. Time taken from A to B is 3.5. Yeah, this is answer. It will come fast now here. So this is also nice. Okay, so this is the first part. Now second part, B to C. S equals to ut plus half a t squared. Formula will be same only. What is u? U. Now what is u? From B to C, what is u? From B to C, what is u? 0. Be very, very careful. You have to be. From A to B, u is 7 because u is initial velocity, not whatever you wrote once. Whole life it will not be u. As I told you, first thing is you have to decide the 2 points, initial and final. Then only you can start using the equations. So from B to C, what is initial velocity here? 0 plus half. Acceleration is minus 2 into 3.5. Wait, what is the time taken? Here is 5 seconds, here is 3.5 seconds. So time taken is 1.5 square. That 1.5 you guys understood. Time taken also you have to be careful. That t was what? T matlab from 0 to t. No, but this is from 3.5 to 5. 3.5 to 5. So time taken will be 1.5. 2 cancel. So S is 2 point, how much? 25. But minus. Minus you understood why it came? Minus you understood because this displacement is here. Let me call this S1. Let me call this S2. This is S1. So S2 is this side. So this minus sign is because of the direction. That's why if you add the two displacements, what will you get? 10. This was your answer. That was the one that you got, Dhruva. Understood? So what you guys calculated before was this. So now what is distance covered if they ask? What will you do? Mod of first displacement, mod of second displacement, because you have to add only the length. How much it will come? 12.25 plus 2.25. 14.5. Am I right? So as you can see, answer is not set. A train starting from rest first accelerates uniformly up to a speed of 80 km per hour for time t. How do I draw diagram? See, how do I draw diagram after reading that you learned? Solving question anybody can do. A train starting from rest, U0. First accelerates uniformly, so A is constant, but they have not given. And it reaches a speed, that means final speed of 80 kilometer per hour. For time t, matlab this time is t. I hope you understood. This t is variable t, this t is given. This t is our variable. It could be 0, like whatever time the clock will show. That time is this. This is the time shown by the clock. For example, this is also t0. This is time of the symbol used for time shown by clock. This is the time actually the clock is shown, 0. Here. Then it moves with a constant speed. So after this, it goes with constant speed. So from here to here, A is illa. No more A. What will be speed here? Anybody? 80 only. Why 80 only? Constant speed they told. But time taken is, then it moves with a constant speed for time 3t. Oh, then this will be 4t because this time taken they have given 3t. Understood this part? Understood this part? The average speed during the whole journey. They want average speed during the journey. For full journey. Full journey matlab from A to B to C. Try once. 70. Maybe correct. Yeah. Tarun also got 70. See, you can use S equal to UT and all. It may take time. I don't know how you people did, but let me try. So, see, the idea is what? Average speed means what? Definition for average speed: total distance. I mean, total displacement by total time. Here, I can say total distance also because it is going straight only. It did not come back. Now, total time, though, I know it is t plus 3t, 4t. That I know, total time. You can see also. Now, total distance also I need. Now, this distance is very easy to write in terms of given because this distance is without acceleration. This distance is without acceleration. And when there is no acceleration, so B to C is the easy part. So displacement from B to C is what? Velocity into time. No need to write half AT square. This is formula. Okay, formula. Now substitute. What is the velocity in this interval? 80. Let us keep it kilometer per hour because options are in that only. What is time taken from here to here? Here it is t, here is 40, so time taken is 3t. I hope you understood. I'm not saying t is 3t. What I'm saying is this is our symbol for time taken. This is what question has given time taken. Okay, 3t. Like sometimes they say, no, my mass is m, your mass is 2m. So in Newton's law, when I write for you, I will write how? F equals to 2m into a. 2m into a doesn't mean you have to write 2 in front of mass. Your mass is 2m, understand? So time taken from here to here is 3t. So displacement though I found from B to C in terms of given. Now from A to B, how to find displacement? If you use ut plus half at square, A will come, no? That is not a problem. What is there? Then we will use one more equation, v square minus u square equals to 2as. So we'll find a from one equation, substitute in another equation. Still we can do. Those equations can solve any problem of constant acceleration. Remember, those three equations can solve any problem of constant acceleration in a straight line. You don't need to memorize any other thing. But since you know A is not given, let us try to skip that one and use this formula. From where to where? A to B. Which formula? From A to B. displacement is average velocity into time. Time taken is how much from here to here? T. Displacement from here to here, let me write AB. And what is average velocity? I told 0 plus AT by 2. Which formula I used? U plus V by 2 or V plus U by 2. So that will be 40T. That's it now. So average velocity for whole journey. Whole journey matlab A, B to C will be total displacement is 40T plus 240T. Total time taken is from here to here, total time taken is T plus 3T. This is 280T. This is 40. 70 kilometer per hour. Okay. Now let me give you some synopsis for free fall. So in free fall, we will study two cases basically. One is a body is dropped and initial velocity is 0. Acceleration is g, magnitude. Direction is down. Whether to take plus or minus, that depends on us. We will decide. Now my style is this. When body is coming down, I take down positive. Life will be easy. I mean, equations will look little bit okay. So when body is going down, I'll take down positive. When bodies are going up, I'll take up positive. Okay. So I'm going to drop a ball, and then we know because of acceleration, its velocity will increase. So when it reaches here, A to B, what will be its velocity if I ask? Standard formula, GT. How much? GT. How it came? V equal to U plus AT. U is 0. I said I'll take down positive. When body comes down, I take down positive. So A is G. So what is V? GT. One more formula is root over 2GH. One more formula is root over 2GH. How it came? V square minus U square is 2AS. Initial velocity is 0. So velocity will be square root of 2AS. A is G, displacement is, let us say, H. This is H. And since H is also, displacement is also down, both are taken positive, so positive. So these are the two velocities, formulas for velocities you should know. Also, they may ask you to find this H in terms of time. So H will be what? Half GT square. Again, how this formula came? S equals to UT plus half AT square. U is 0 and displacement is H. A is G. Sometimes time taken they will ask. Then it will be root over 2H by G. So please guys memorize these few things. Which are the formulas you should memorize? When a body falls a height h, its velocity gained is root over 2gh. Similarly, when a body falls a height h, time taken is root over 2gh. And if time taken is given, then the height it falls is half gt squared. Please memorize, we can do problems fast. And second case of free fall is when you throw a ball up with some velocity. Now acceleration of gravity is down. So while going up from A to B, here you know it will return. So here velocity is 0. So now it is going up. So when it goes up, what was my style? Up is positive. Now if they ask you what is the maximum height it travels, maximum height from here to here, then the formula for maximum height is u square by 2g. Or if somebody gives you maximum height, If somebody gives you maximum height and asks you to find the initial velocity, what will you do? Root over 2gh. Okay, similar formula like before, if you remember. But before it was coming down, now it is going up. How this formula came, sir? V square minus u square is 2as. Final velocity here is 0. Acceleration due to gravity is minus g. Why minus g, sir, suddenly? I told no, while going up, I take up positive. So if I take up positive, acceleration of gravity, so always down it is. Whether you go up or you don't go up, it doesn't matter. Whether you sleep or brush or whatever you want to do, you do. Acceleration due to gravity is down, is constant. So A is minus G. Displacement will be up, so positive. And the displacement is from here to here, which is maximum height it could go. By the way, when it comes back, when it reaches here, if somebody will ask you what is the final velocity, what will you say? While coming back to I did previous cases, previous case is coming back only, no? From 0 speed to this speed. Put thumbs up, yes or no? When it is coming back, that is same as previous case. So what will be V? Root over 2gh, but h is h max. Oh, acha. One thing what we understood. If you throw with speed 10, when it comes back, it will also have speed 10. Of course, direction will be opposite. So velocity wise, if you write, if initial is plus 10 j cap, final will be minus 10 j cap. Provided by initial and final, you mean the same level. And so here, this formula and this formula you need to remember. How much time it takes to go up if they ask? Time taken to go up. That will be quite simple. You can use V equal to U plus AT. Final velocity here is 0. U is positive, U up, A is minus. So time of ascent matlab while going up, is U by G. And because there is symmetry, whatever time it takes to go up, same time it takes to come down. So this is also time of descent. Ascent matlab from A to B, descent matlab from B to A. So if somebody will ask what is the time of flight, what will you say? Time of flight in vertical motion. U by G while coming down, U by G while coming, U by G while going up, U by G while coming down. That will be 2U by G. Okay. So question number 2 for us, today's class. A gas balloon is going up with a constant velocity of 10 meter per second. When this balloon reached a height of 75 meter, a stone is dropped from it. So when the balloon is at a height of 75 meter, and remember balloon was going up with constant velocity. Balloon's velocity is constant, 10 meter per second. So when it was at a height of 75, a stone is dropped. A stone is dropped. And the balloon keeps moving up with the same velocity. The height of the balloon when the stone hits the ground. So this stone will ultimately come to ground. So when it hits the ground, when the stone hits the ground, how much height the balloon has, they are asking. First of all, tell me what is the initial velocity of stone. Remember, it's dropped. So what is the initial velocity of stone? Bapre, so fast. Arey wah. Bella could change the answer. Tanu correctly. Students, you should remember something called what Shia? Inertia. Inertia says your velocity cannot change in. Oh, today only I discussed no electrical inertia. Inductor doesn't allow current to change instantly. Similarly, the mass of the stone will not allow its velocity to change instantly. When the stone was dropped, just before dropping, where it was? In the balloon. What balloon was doing? It was moving up with constant velocity. So stone was also moving up with constant velocity. No. So at that moment when you drop the stone, its velocity, initial velocity will be 10 only. This part is tumba important because it was not dropped from rest. From rest, if I drop, zero initial velocity from ground frame. All these problems we are doing from ground frame. After few Sundays, we will be doing relative motion. So that time you will understand if I change the frame of reference, how the answers will change. But right now, if I don't mention anything, it is done from ground frame of reference. Okay, students. So when you see from the ground, this stone will have same velocity as the balloon. So when you drop it, your hand is going up. Whoever is dropping, God knows who it is. So when that person will drop the stone, that hand was moving with the balloon because the man was in the balloon up. So this stone will not come down now because though gravity is acting, I know it is already moving up. No, so it will continue to go up and then come back. So this will be the path of the stone. Okay, students, as seen from ground. So I can use my equations this way also. Look here, I can use my equation from A to this point, then from that point to this point. That way we can do. That way if you do, you don't have to solve any quadratic equations. But why to waste time? I will do directly from A to B. Okay, so this is the motion. I told you any 2 points can be chosen. So A and B. As long as the motion is under constant acceleration, you can choose any 2 points. So let us do carefully. S equal to ut plus half at squared. Why I am using this formula? Because the body went from A to B. So this will be your displacement. And since finally it came down only, see, it may be going up, but finally it came down. So since it is coming down, finally, I am going to take down positive. Don't forget my style. So what is displacement? Down, how much? 75. What is initial velocity? 10 up. So minus 10. I hope you understood why minus, because initial velocity is up. I have taken down positive. Acceleration due to gravity, 10 only I will take. Okay, so A I will take G, which is 10. And it is down, so I have taken down positive. 2 5s are 10. So I will get 5t square minus 10t minus 75 equal to 0. What did I do? I took 75 there. Let us divide by 5. 5 2s are 10, 5 1s are 5, 2 carry 5,000. Can anybody give me the two solutions of this? What into what is 15? 5 3s are. Am I right? So t square minus 5t plus 3t minus 15 equal to 0. T minus 5 plus 3 t minus 5. So what are the solutions? 5 seconds and minus 3 seconds. Minus 3 seconds not possible. How can I drop now and it will reach 3 seconds before? It's like I started today, but I reached yesterday. That is nonsense. So what is the time taken from here to here? Positive solution we have to take 5 seconds. Can we do from here to here also? Shall I show or no need? So let me break this motion now, A to C. A to C, which formula to use? Height, though I don't know. So V equal to U plus AT is better. V is 0, U is 7, A is minus 10 into T. So time taken from A to C is U is 10, no, what 7? So time taken is 1 second. This is from where to where? A to C. Then you do from C to B. Now C to B, you need this displacement. This much is 75. How much is this one? Let us calculate, because they may also ask you how high the stone will rise. Who knows? In another question. How high the stone will rise. So the stone starts with what initial velocity? 10, same as the balloon. So this is the maximum height traveled by balloon. Sorry, traveled by stone. So what was the formula for that? U square by 2g. That formula I gave you, which will be 10 into 10. 2 divided by. Here don't use sign, okay? Because all this was derived with sign only. So 5 meters. So maximum height is 5 meters. So from C to B, what is the displacement? This is 5, this is 75. So what is the total displacement? 85. And what was time taken while coming down? I told you root over 2h by g. Remember this formula? When you come with 0 speed, you are starting with 0 speed. Remember, here speed is 0. Shall I use s equal to ut plus half ut square only? Okay. S equals to ut plus half at square. Tell me, from C to B, what is your initial velocity? 0. A is 10. Down I take positive while coming down. Displacement is how much from C to B? Here is 5. Here is 75. So 80. So time taken from C to B will be 80 by 5. The 2 5s are 10. 5, how much of 80? 6, 5 16s are. So what will be? This is time square. So what will be time taken? Square root of 16, 4. So what is time taken from A to C to B? 1 second plus 4 seconds. How much? 5 seconds. Which one is better? Quadratic one is better or this is better? So we came to know the stone reached in the ground after 5 seconds after it was dropped. Now during that time, 5 seconds, where is the balloon that they are asking? Now for balloon, what will be the equation? Okay. So remember, balloon was starting from here and the height of the balloon was 75 when the stone was dropped at t0. Then stone went like this and stone here reached after 5 seconds. Now remember, balloon is going with constant velocity 10. Therefore, in 5 seconds when stone came here, balloon, so it will keep on going up only. So let us say balloon reached here in 5 seconds. So this is displacement of balloon in 5 seconds. B for balloon. Now what will be equation for balloon? Equation for balloon will be displacement will be velocity into time. Tell me what happened to that half at square? Because in question they told balloon is moving with what velocity? Constant. Very good, Nishta. So since balloon is moving with constant velocity, acceleration of balloon will be 0. But sir, it is moving under gravity. Why are you thinking more than what question told? Question told no velocity of balloon is constant. That means balloon is not under free fall. And usually, no, balloons experience other forces besides gravity. Do you know that? Buoyant forces, or there will be some air, they will heat the air and then it will expand. So buoyancy will take it up. Yes or no, students? So usually balloons, that air balloons which are there, they experience other forces besides gravity. And if you feel other forces besides gravity, then you are not under free fall. Then it is possible that I cancel mg with my buoyant force, and then I can go with constant velocity. Stone was obviously under free fall. Once the stone was dropped, it was under the love of gravity. No other forces. mg only. Understood? So when v is constant, a is 0, and if a is 0, you can directly write what formula? Your school formula. What was the formula? Displacement is velocity into time. So velocity of balloon is constant. T is 5. So it is 50 meters. So balloon traveled 50 meters more. Therefore, height of balloon when the stone reached the ground is 75 plus 50, which is 125 meters. Option. I'll take a printout of this and give to you people. Okay. Option D. Next question you see. Water drops from a tap on the floor 5 meters below. So there is a tap which is 5 meters on a floor. The floor is 5 meters below the tap. The first drop strikes the floor. Now water drops fall from the tap at regular intervals of time. So drops fall at regular interval. That is tumba important. Regular interval matlab after 2 seconds, let's say I'm dropping. So one drop, then after 2 seconds, one more drop starts. Then 2 seconds, one more drop starts like that. Or let's say 0.5 seconds. So first drop starts after 0.5, one more drop starts after 0.5 seconds, one more drop starts like that. So regular interval. The first drop strikes the floor when the sixth drop begins to rise. Begins to fall. Sixth. Then fifth will be somewhere here. Fifth, fourth, third, second. Okay. The gap will not be obviously same. Okay, because you know the motion is under gravity, so they will move faster. Anyways, the height at which the fourth drop will be from the ground. Fourth drop. This question they are asking. Try once. You can use direct equations of that free fall, because here you know all the drops will start with what velocity? 0. Tap is not moving, no? This time it is tap, man, not balloon. First, try to find how much time it takes for first drop to reach here. That is easy because height is given. So if height is given, time taken, though I told you, no? But again, when can you use that formula? If the body starts with 0 speed. All of them start with 0 speed only. So first find the time taken. Then you see if that is the time taken, then what is the interval between the drops? After what interval the drops are falling? The interval you need. Once you know that interval, then you will come to know how much time the fourth drop has fallen. Once you know how much time the fourth drop has fallen, you can find this distance. Once you know this distance, you can find this height. Simple. Let us first calculate time taken by any drop to reach the floor, because all of them will fall with 0 speed. All of them will travel 5 meters. So time taken by any drop, let's take first drop, time taken by first drop to reach ground. T, what is the formula? Root over 2h by g. Fast we will do now, okay? How this formula came? From which formula? S equal to ut plus half at square. So h is 5, g is 10, so 1 second. So all the drops took 1 second. Now think carefully. First drop started here at t0. then 1 second it reached here. During that time, sixth drop is there, sixth. Then can you tell me what is the interval between the drops? There is this gap, 1 gap, 2 gap, 3 gap, 4 gap, 5 gap. No, 5 gaps are there. It cannot be T by 6. Gaps are 5. Sixth drop has not still fallen. No, Tanu. Sixth drop is starting. Look here. First drop starts. Then second drop starts. Let's say the time interval is X. X seconds. Okay, so keep count. Keep count, all of you. Stop writing. Padmavati, stop writing. Think. First drop starts at T0. And after X seconds, second drop starts. One more X second, second drop starts. How many seconds passed? Array, X passed, then second drop. Then third drop start, 2X. Fourth drop, 3X. Fifth drop, 4X. Yes or no? Sixth drop, when it starts, it will be 5X. 5X time it took. And during that time, what they told, first drop reached the ground when sixth drop starts. So 5X was the time fallen by first drop. So if T, what to write? If delta T is the time interval between drops, then delta T must be T divided by 5. Will you please remember, if 6th drop, then 5. Because in exam, they may put here 10th drop or 11th drop. Then who will be here? 10. Don't forget it, okay? That will be 1 by 5. Oh, acha, you're correct only. Supriya. 0.2 seconds. So now we came to know that every drop travels for 0.2, then second drops, then next drop will start. So fourth drop fall for how many seconds? Fourth drop has fallen for how many seconds in this picture when first drop is here? When fourth drop started, it was here. No, then when fifth one will start, fourth drop is here. So it has fallen for X seconds, I told, if X is the interval. Then when sixth will start, fifth will be here, fourth will be here. So fourth drop fell for how many seconds? 2X. That means fourth drop fell for 2 into delta T seconds. That means 2 into 0.2, 0.4 seconds. So once we know fourth drop fell for how many seconds? 0.4 seconds. Now I can find distance covered by fourth ball. That is easy. Distance fallen or height fallen how much height it has fallen? This height. Let us call this height as h dash. Then what will be h dash? Half g times square. How much time it has fallen from here to here? 0.4. So this will be 10 into 0.4 into 0.4 divided by 2. 0.2. 0.8. So it has fallen for 0.8 meters. So what will be its height? So what will be its height? Height of fourth drop. 5 minus 0.8, 4.2 meters.